Hello, my name is Miranda.
Lady Lannis,
Angie,
Julia.
The title of the study is Different Brain Activity in Response to Emotional Faces Alone and Augmented by Contextual Information
by Kung-Wai Lee and Greg J. Siegel.
The study was conducted to see how emotional faces alone differ from emotional faces in context, and how that relates to neural activity. How the brain reacts to emotional faces. The study is important because it shows how emotional faces alone misrepresent real-world context. We know that studies have been done on emotional faces and the regions in the brain that are activated when seeing these faces. But the study shows how different regions in the brain are activated when adding a context to those faces, making them more emotional. The researchers hypothesized that faces with context would be rated as more intense compared to faces alone. This would seem to make sense because you can gather emotion from a face much better by seeing the context in which the emotion is in. Like in this example, you can see how this man is happy because of the context of two children in his arms. Although the researchers hypothesized that the faces with context would be processed slower and would use a wider brain network than faces alone because there is more information for the brain to process. In this example, you have to notice the children and their faces along with the man's face as well. The researchers also hypothesized that the faces with context would activate the prefrontal and limbic regions, whereas the faces alone would activate the subcortical, limbic, and temporal regions and would be processed faster. The researchers expected to find that faces presented alone would show early neural activity.
Methodology. The independent variable was affective pictures. They were divided into 4 groups: face, no face, face and context, and others. The dependent variables were brain activity during recognition of faces, the emotional intensity and arousal, as well as the effects of negative and positive emotions of faces. The design of the study was a within-subject experimental design, since all participants were exposed to all conditions. Participants. 20 subjects participated in this study. Participants has no current or history of psychiatric disorders. Procedure and measurement. Researchers classified stimuli into 4 groups: face, no face, face and context, and others. There were 15 positive and 15 negative emotional pictures. Positive emotional pictures represent happy social situations, while negative emotional pictures represent sad and other negative situations. A slow event-related design was employed to prevent amygdala habituation effects associated with fast presentation of emotion advocating stimuli and to allow examination of the time course on event-related responses. Subjects were presented with randomly ordered stimuli of emotional faces with contextual information of emotional faces alone for 6 seconds, allowed by fixation cross. Subjects were instructed to press a button as soon as possible when the stimuli appear on the screen. Researchers used the simple button press to encourage subjects to maintain attention of each stimulus. Then participants were scanned. Researchers used fMRI analysis were conducted using locally developed neuroimaging software. Researchers used model-free analysis for empirical variation in the shape of hemodynamic responses, which was the sustained activity at 8.5 through 12 seconds after the onset of emotional stimulus.
After the scan, participants were asked to evaluate their subjective emotional response to each emotional stimulus, which was measured using the self-assessment mannequin. The self-assessment mannequin consists of graphic icons depicting values on a continuously varying scale reflecting emotional reactions. The main results of the study found that emotional faces augmented by contextual information were rated as more effectively intense than emotional faces presented alone, activated a wider array of visual and prefrontal regions than emotional faces alone, and that the prefrontal region activations vary with subjective emotional intensity. They also found that emotional faces presented alone were better activators of limbic and paralimbic regions, which are associated with automatic emotional processing. Overall, they also found that both types of stimuli activated areas of the brain known to be involved in general social and emotional processing, in addition to visual processing regions.
The primary hypothesis is that emotional faces with context will activate a wider brain network compared to emotional faces alone, which was supported at the 0.05 level. A two-way ANOVA was conducted and revealed a main effect and a significant interaction. In addition to the first hypothesis, the study also predicted that prefrontal and limbic regions associated with the emotional face and context, and that faces alone will activate subcortical, limbic, and temporal regions. The second hypothesis was supported, showing a widespread brain activity in the left prefrontal cortex and in the medial prefrontal cortex. The third hypothesis was supported, showing brain activity in the limbic and the temporal regions. Results show significant effect on the medial prefrontal cortex and show no interaction based on the emotional intensity. This means that emotional processing of face relies on brain regions associated with relatively quick automatic emotional processing. It may support that automatic processing of emotional faces associated with the amygdala. Subcortical limbic regions such as left amygdala extending to the parahippocampal gyrus show particularly robust early neural responses to negative faces compared to negative faces with context.
This study was valid because they used emotional pictures selected from the well-validated International Affective Picture System database. They also controlled for confounding variables by editing the same context pictures to only show a single facial expression, which they then used in the emotional faces alone condition. Some limitations to the validity of this study include that they did not use neutral control stimuli, since it would not have helped answer questions regarding modulation of subjective emotional experience by ecological stimuli. Without having well-defined control stimuli, they cannot be certain what functions the prefrontal and visual regions may have in emotional and visual processing. Another limitation of the study was their use of a passive viewing task, which prevented them from directly examining how specific semantic and other cognitive processing influenced their findings. The external validity of the study was also poor due to the relatively small sample size. Some other factors that may explain their findings include that contextual information may allow people to link their own personal experience to emotional stimuli, increasing their subjective emotional experience. Some of the observed effects could have occurred in neutral faces or scenes without faces, if those effects were due solely to low-frequency visual regions or complexity. Some strengths of the study include their consideration of potential extraneous variables, which past studies had not controlled for. They attended to emotional factors known to influence brain function, including emotional intensity and arousal imbalance. The results of the study may have practical implications in future emotion research. Their results suggest that simple faces may represent excellent stimuli for studies observing activity associated with relatively quick, automatic processing of emotion and social processing of faces. For studies on reactivity to emotional stimuli or on brain activity associated with subjective emotional responses, contextual augmentation may achieve activation throughout brain networks associated with emotional, social, cognitive, and visual processing.